Hey guys, so today's video is going to be to describe how to disassemble, repair, and reassemble a hydraulic vane pump, similar to all those found on our snubbing units and our service rigs. And while we're at it, we're going to take a little bit of a deeper dive into how the vane pump itself works and give you guys a little more confidence out in the field there to attack these problems when they arise. So the goals of today's video: disassemble the pump itself, reposition the ports if needed, remove the cartridge, how to tell the direction of spin of the cartridge as well as the displacement, how to install a new cartridge, and then just the best practices for safe reassembly and put back into service. A few notes before we get started. Big one's going to be you want to maintain a clean work area. There's a lot of tight tolerances inside these pumps, and if you have little bits of metal or dirt or anything in your work area, they tend to get lodged inside the pump, and then they can quickly cause issues inside. So you're going to want to make sure you got clean hands, clean gloves, and clean work surface as well. A couple other notes on that is some lockout tagout points. When you are getting ready to remove this pump from the gearbox in the power pack, a couple things you want to do is you want to make sure your suction valves are closed on under your hydraulic tank, obviously, so when you remove the suction hose here, you're not going to lose all your hydraulic oil from the tank. For the pressure side, a lot of times you're going to want to do is disconnect your hoses coming from the unit. If the unit's standing up in the air, when you disconnect the power hose from the pump, what will happen is all the hydrostatic pressure in the hoses up to the unit is going to all drain the oil back out of your pressure side, and it's going to make a colossal mess. Close your suction valves under your tank, disconnect your Dixon couplers on your power pack, and that should minimize the quantity of oil that gets spilled when you remove this. Obviously, if we're disconnecting the mechanical pump from the gearbox, you're going to want to shut off the ignition of the engine, and it's a good idea to actually take the key out of the ignition so no one can come and start up the engine while you've got the pump disconnected. Final point on lockout tagout is stored energy in the hydraulic circuits. Before you remove any hoses, what you're going to want to do is go to your hydraulic panel, make sure all the bypass valves are dialed out, no pressure is stored in those hoses or in any of the hydraulic circuits. Most notably is going to be the accumulator circuit. It's got the pressure in all four of those bottles. If you disconnect the pressure hose, even with the engine shut off, you're still going to have a significant amount of pressurized oil stored in those bottles, and it'll all come out and could be incredibly hazardous. So double check those lockout tagout points before you disconnect any hoses, and that's a pretty key point to performing this safely. Okay, so one of the main things about rebuilding a pump is you have to make sure that the pump is spinning in the correct direction. So each hydraulic pump cartridge is set up to spin in a certain direction. If you miss that point or you don't set that up properly, then what you're going to end up is having suction on your pressure port and pressure on your suction port. Obviously that's not going to work when it's rigged back up onto the unit. So when we're disassembling a pump, we're going to take care to ensure that they're set up to spin in the correct direction. Most of the pumps at Deepwell are going to be counterclockwise rotation pumps, and these will usually come out from the parts department already set up from the manufacturer in the counterclockwise direction of rotation. But if you're replacing a cartridge inside the pump or doing any work disassembling, you're going to want to know how to check for the proper direction of rotation. The direction of rotation is always noted from the side of the input shaft. So when you're looking at a pump like this is the side that's getting bolted onto the gearbox. So this is the input side of the pump. So all direction of rotation is going to be noted from this direction. So if we're looking at a counterclockwise direction of rotation, we're going to want to look at it from this end, and you're going to see that the pump is spinning counterclockwise. Definitely note that. If you got to make an arrow on there with some paint or some chalk, go ahead. But all the pumps at Deepwell standalone units are going to spin counterclockwise or to the left when viewed from the input shaft end. Most of the cartridges that we stock on the shelves are going to be pre-set up for counterclockwise spin, but we'll show you how to check that when you get a new cartridge sent out, just to make sure that nothing's getting missed. Another note is a lot of the pumps on the equipment are double pumps, and some of them are single pumps. So what that means is on this particular pump, we have one pressure output port, one suction port, and so that means we have one cartridge inside this pump housing. Some pumps are set up to have one suction and two pressure discharge ports, which means they'll have two separate cartridges. Basically, you'll have one shaft running through, driving two cartridges. It'll work off one suction hose, but there will be two pressure discharge hoses. So it is important to note that. We'll get into some of the details a little further on about the implications of having multiple cartridges in one housing. But this is a single pump. A double pump would have another pressure discharge port right here, and you'd still have to take note of the direction of spin to determine what direction each one of those cartridges are spinning inside the housing. So let's get this thing apart. This on the table here is a double pump. So what you'll see is, again, it has a single suction port, but it has two discharge ports. So which means on the inside of this housing, you'll have one cartridge that outputs pressure on this end of the pump and one cartridge that outputs pressure on this end of the pump. So basically you get two discharges for one suction, and it cuts down on hoses for your power pack. Okay, so if you're looking at the suction port of a double pump, you can see up here there's a cartridge in the front, and then you'll see there's a big main cartridge below it, and they're separated by this steel plate. But they're all driven by the same shaft that goes through and drives both cartridges. So if you're looking at the suction side, you'll be able to see a whole nother cartridge in a double pump compared to a single pump. So now we're going to get ready to disassemble or separate the housing and disassemble the pump, remove the cartridge. So a couple notes here. Again, we've got our counterclockwise rotation as seen from the input shaft end. And then you also want to make note of the orientation of your two ports. So we'll discuss how to change the orientation of these ports in a minute. But if your intent is to reassemble the pump in the exact same way that you took it apart, what you're going to want to do is mark the orientation for reference afterwards. So in order to do that, what we're going to do is take a hammer and a punch, and we're going to come to one side and we're going to make a mark. And so that way we have a reference that when we line these two punch marks up, we know that this housing is lined up the same way it was when we disassembled the pump. The last thing you want to do is go through the whole process of reassembling the pump, torquing everything back down, only to notice that your ports have been shifted and the whole thing is a waste. So mark your housing, and then we'll start breaking apart these bolts. Obviously, we'd hope that those bolts are tighter than that, but we had the luxury of breaking them beforehand. Quick note, if you are looking to change the orientation of your ports, which is quite often the reason why we're working with these pumps, is because you got sent out a new pump from the shop, but it's not set up in the proper orientation that you need to bolt it onto your gearbox. You're going to want to change the orientation of the ports. So we'll go over that briefly now. Grab a couple long 5/8 bolts and stick them in through here. And that way what we can do is we can have two pry points that are up above this shaft. So once you've determined what direction your ports need to be in, for this example, we're going to say that we have to shift this cap 90 degrees to the right. We've broken the bolts out, we've taken them out, and now what we're going to do is take a pry bar and we'll put them in like this, and then we're going to turn this upper piece of the housing to the right. One note is you don't want to have these two pieces of houses separate while you're rotating. What that could do is allow the cartridge inside to lift up and fall out of alignment. It could also allow the seal that exists between these two pieces to fall out of the groove, and then when you tighten it down, you'll crunch the seal and it won't hold. So you're going to want to watch that this seam doesn't open up as you're turning, and you're just going to want to turn it to the desired position. Perfect. So that was the direction, the orientation I wanted to make it. I didn't open the seam. It's lined up, and if that's all I wanted to do with this pump today, I would just go ahead and ensure that these bolts are lined up, put some never anti-seize on them, and go ahead and run them back in and torque them up. But for today, obviously, we're going to keep going a little further. So now we're going to pull the actual cartridge out of the pump. Okay, so now obviously this in the field, this could be a lot trickier. A quick note, if you are going to hammer anything on these pumps, guys, it's best to use a rubber mallet, but if you do have to use a steel mallet or a steel hammer, you want to try to use a piece of wood, you know, so if you're tapping the shaft or anything, that you're not actually having that metal on metal contact that could damage parts of the pump. So hopefully this comes out nice and easy. Okay guys, so there, when I took this out, the cartridge came out with the cap. So they came out together. What I don't want to do now is lift this up and then have that cartridge slide off the shaft and fall onto the floor and get damaged. So if this cartridge does come out together, just take care to lift them down and leave them together until they're on the table where they're not going to fall apart. You might be inclined to use a pry bar or a wrench and hammer this down to get this off. But again, you're going to want to try to use a piece of wood or something that's going to not damage the pieces of the pump. Okay, so once you get your cartridge, your housing separated and your cartridge out, an important point before you go and wipe everything down, which is usually our first instinct, we want to be looking at the cartridge and looking inside the housing for any signs of wear and tear. You're going to be looking on your cam ring, seeing if there's any obvious chunks of metal that are sitting in there, anything that might indicate why the pump failed. Usually the pumps fail because there's some sort of contamination in the system or some sort of piece that's gotten in and scarred or deformed the interior. And so we just want to have a look at that because that could go a long way in diagnosing a problem and keeping it from happening again in the future. So have a quick look at the pump, have a look in the suction port, see if there's any accumulation of pieces. Look inside the housing. Also check your seal here to make sure this seal that runs along this joint right here is intact as well. Once you're satisfied that there's no damage, or if there is damage and you've taken pictures of it all so that you can send it in for investigation, then you can just give it all a quick wipe down. Okay guys, so when you're wiping it down, you're inspecting the housing. What you also want to feel for is just any burrs, okay? Or again, if there's any debris that's accumulated inside. So every cartridge has two pieces of information. It has a direction of spin like we talked about earlier, and it also has a certain displacement. So this displacement tells us how many gallons per minute this pump cartridge is going to put out when it's spinning at a given RPM. And all of this information is going to be stamped here on this piece that we call the cam ring, and it'll be visible once you take the cartridge out. So here it says VT6-72, and then there's an arrow that points in that direction. So what that means is VT6 is the model of the cartridge and the pump, and the 72 indicates it's a 72 gallon a minute pump. Okay, and then this arrow indicates the direction of the spin of the rotor inside the cam ring. What that's saying is that if you were to have an input shaft driving this cartridge, the arrow's pointing that way, and the rotor inside the cartridge would spin in the direction of that arrow. Okay, and that has to do with the suction ports that allow oil to get sucked in, and then how they line up with the discharge ports on the bottom of the cartridge. So if your pump's spinning in the wrong direction, it's not going to suck oil in through these intake ports, and it's not going to discharge oil through the output ports. It's going to do the opposite. So that's something very important to take into consideration and to note when you're dealing with these cartridges. Once you're comfortable with the direction of spin of your cartridge, you can stand it back up. Now, if you were simply replacing the cartridge in the pump, you would have had a new one of these sent out to you from the shop, and all you would want to be doing now is taking the old cartridge, sending it back, and taking the new cartridge and reassembling it into your pump housing. For the purposes of this video today, we're going to actually disassemble the cartridge, but just know that generally in the field, you're not going to be taking this to this step because we would just send you out a whole new cartridge to begin with. Inside this end of the housing, obviously the shaft comes in. The shaft is held in place by a snap ring in here, and then there's also a seal assembly on the shaft that prevents pressurized oil from escaping out along the shaft when it should be escaping out of this port right here. So if you are having a leaking shaft, or if the bearings on your shaft are destroyed, you would simply take out this snap ring, and then you'd be able to remove the shaft from the housing, such as we did on this one. So that shaft would fit down in the housing. You remove the snap ring, and you got a seal assembly in there, and there you'd have your shaft separated from your housing. Today we're going to leave this piece together because there's nothing wrong with it, and we're going to come back to the cartridge. Okay guys, so now we have the cartridge removed. Again, we probably would never dive this deep into it out in the field, but we're going to disassemble the cartridge for your own sake, just so you have a better idea of what's going on in there and how these things work. You have two rubber seals, one down here on the neck, and then right here where the cartridge slides into the housing, you're gonna have a rubber seal and then a Teflon backup ring. So obviously, just like any other piece we're assembling or disassembling, before we put it all together, you're just gonna wanna double check those seals and make sure that they're intact before you put the new cartridge in. Spread a little bit of hydraulic oil on them so that they fit down in and they don't get cut while we're putting them in. So a couple points about the cartridge as a whole. Obviously with any pump, you're gonna have intake and suction pieces, and then you're gonna have pressure or output pieces. So these cartridges actually have three separate intake ports. This here, this hole in the cam ring, and then this hole up here. All three of those orifices suck in low pressure oil into the cartridge for discharge afterwards. The discharge pumps on the cartridge are found here on the bottom. So these two holes here are actually where the pressurized fluid come out of the cartridge and get pushed out to the hose. When you're looking at the pump, the housing section, where this cartridge slides into, you can see generally that this rubber seal is going to seal the suction half of the cartridge and keep it separate from the pressure portion of the cartridge. And then you'll see how these pressure discharge ports on the cartridge meet up, and then the pressurized fluid flows out of the pressure port in the housing. And then conversely, these intake ports will line up with the intake or suction port on the pump housing. So that's a little bit about the theory behind the cartridge. Now we're going to take it apart and have a look at the insides of it. Okay, so we're going to disassemble this cartridge now. So now we're going to separate the cartridge into its four components. Here's your rear plate, here's your cam ring, your rotor, and then your pressure port plate. Like we spoke about earlier, when you are disassembling a failed pump, this is quite often where you're going to see signs of wear and tear. So before you go wiping everything off, you're just going to take note, maybe take a couple pictures of any damage or debris that you find in here. That could go a long way in helping determine why the pump failed. So I do have a damaged rear plate here. You can see there's significant scarring. And so this is all stuff that we'd like to note that might indicate that there was contamination in the hydraulic system, and that we might need to look into it at a more systemic level and make sure the other pumps aren't going through the same sort of having the same issues. So there's your rear plate. And now what we have here is the actual internals of the cartridge. Okay, so here we have the inner pieces of the actual cartridge itself, and it gives you a good idea of how the pump actually puts out fluid. So in here in the middle we have the rotor, and this rotor is the actual piece that gets spun by the input shaft. You can see that there's an internal gear here that matches up with the external spline on the shaft, So in effect, inside the housing, this outer piece of the cartridge doesn't move, but the internal rotor in this cartridge gets spun, okay? And again, if you're looking at the indications on the cam ring, it's getting spun in the direction of the arrow. Okay, another note is the elliptical shape of the inside of this cam ring. These are called the vanes, and as it spins, these vanes all get pushed out and they'll track along the inside of this cam ring. So as this turns here, the volume inside this space between the rotor and the cam ring increases, and then it steadily increases as the rotor spins around until you get to 90 degrees from where it started and the space begins to decrease. So this is the same principle as inside a combustion engine, inside the cylinder. When the cylinder or the piston inside the engine drops down, it creates a vacuum or a negative pressure, which sucks in the air-fuel mixture in an engine, or it'll suck in hydraulic oil through the intake ports into the cam ring. Then, as the rotor continues to spin, the volume inside that space decreases. As the volume decreases, the pressure inside the space increases until it lines up with the discharge port, and then all the pressurized oil inside those spaces gets expelled out of the discharge port and then out of the discharge port on the housing. So in effect, that is how the rotor and cam ring take in fluid, compress fluid, and then discharge fluid. It happens on this half of the cam ring as well as this half of the cam ring. So you have two intake sections, two discharge sections. We call this a hydrostatically balanced vane pump. Having a discharge section and intake section on both sides in direct opposition to each other removes any lateral force on the cartridge. If you were to have just a pressure on one side, it would apply a sideways pressure to the shaft and it would cause bearing failure. So these are hydrostatically balanced cartridges meant for long life and high pressure output. So next step, I put these bolts back in just to hold it in place. But now what we're going to do is look at the cam ring itself. So this cam ring slides off like that. Okay, it's got its own designated marking. It's got these dowel pins that line it up with the pressure plate and the rear plate, and it has the holes that the bolts pass through. On the side, it's got the intake ports. You're going to want to look inside if there's any major signs of wear and tear on the inside of the cam ring. Here's another cam ring, just for comparison. So this one's a 72 gallon a minute. This one's going to be a 66 gallon a minute. But as you can see, the 66 gallon a minute cam ring will fit onto the same cartridge as the 72 gallon a minute. So if we were interested in changing the displacement or output of the pump, this is how we would do it. We would swap one cam ring for another, and then that would change the output of the pump. Here's our rotor. Okay guys, the rotor is set up with vanes. So these vanes are what actually track along the inside of the cam ring to pressurize the fluid or to create pressure. Okay, when you take a pump apart, a lot of times the vanes will pop out. They have to go back in the same orientation, but they can flip in this sense, but you can't have the concave side facing inwards. So you have to make sure that the right edge is facing out. And then also to watch out for is these little pins. These little pins will fall out, and when you put these pins back in, there's one end that has a conical face and one end that has a flat face. If those fall out, that they got to get put back in the right fashion. So now that the rotor's apart, the cam ring's off, this is called the pressure plate. Okay, and basically it's called the pressure plate because it has the ports where the pressurized fluid gets discharged. Again, just like the rear plate, what you want to do is just inspect it for signs of wear. This one looks pretty good, but if we have a look at this one over here, you can just see complete disaster. So there's all sorts of gouges, it's all mushroomed out there. This pump failed catastrophically, and obviously if you were to note this kind of wear and tear on the pieces when we take it apart, you're not going to want to reassemble it for use again. That destined for the scrap heap. Okay, and likewise this cartridge, guys, the vanes aren't moving. They're all bound in there. Some of them are broken. Again, this rotor, no good. Those are all the interior pieces of the vane pump, and now we're gonna look at putting it all back together. So now what we're gonna do is reassemble the pieces of the cartridge. So you have your pressure port plate here. Okay. We're gonna put our rotor back on. Again, if the vanes fall out, what you wanna do is make sure that you put them in with this grooved or concave side facing out. So once that's on, we're gonna reinstall the camring. And the camring is what determines the direction of spin and the displacement of the pump. So the rotor, the orientation of the rotor isn't as important as the orientation of the camring. So if you see the dowel pin on the camring and the hole for the bolt on the camring, they're gonna line up with the hole for the dowel pin on the rear pressure port plate and with the hole for the bolt. Okay, so these ones are gonna line up, and then as you can see, that would allow the bolt to go all the way through into the hole. Now some of these cam rings allow you to flip the cam ring and put it on in the opposite direction. And what that would effectively do is if this cam ring wants this rotor to spin this way, if you were to flip it over, it would now have the rotor spinning the other way. So this is how you change the direction of a pump cartridge. We won't have to do this on deep well units because we'd just send you out a pre-set up cartridge. But for future reference in your careers, you would just take that, flip it over, and then that effectively changes the direction of rotation of your cartridge. Now the reason it doesn't work for the deep well pumps is because now this bolt hole is all the way over here and it doesn't line up with the bolt hole here. So that's why with this cam ring, you cannot change the direction of spin for this cartridge. It has to get reassembled the same way you took it apart. So once you put the cam ring back on, your direction of spin is good. All your vanes are in properly. You're gonna take your rear port plate and you're gonna put it back on as well. Okay, it also has a pin for the dowel, or a hole for the dowel pin and then hole for the bolts. So really there's only one way that you're gonna be able to reassemble that, and that's gonna get everything to line up properly like that. Then what you're gonna wanna do is take your two bolts and get them back in there. So this is gonna be an important part of the reassembly that's gonna save you a headache down the road. You wanna make sure that all these pieces, the two port plates and the cam ring, are lined up properly. So when you go to reinsert them into the housing, they're all gonna line up. So what you can do is start the bolts, but leave them fairly loose. Get them close, and that way you can still wiggle the pieces of the cartridge to make sure they're absolutely as straight as possible. And then you'll just snug that up and just double check that all those pieces line up properly. So there you have the totally reassembled cartridge. Whether you change the cam ring, change the rotor, whatever it is, it's now completely reassembled and ready to put back into the housing. Again, like we noted earlier, you can take note of the displacement and the direction of spin of the cam ring. And what you can also do is you could take your shaft. Now, normally it would still be in the housing. You could put it in, and then you just want to make sure that that rotor is spinning freely inside that cam ring. Okay? There we are. We're fairly confident that that is put back together properly. We're going to have another quick check of our two seals and our backup ring. Make sure those are all good. And then we're going to look at reassembling the cartridge into the housing. So now we're going to reinstall the cartridge into the pump housing. There's one major point that I want to make to emphasize a bit here, and that's the position of this nipple here. So what this nipple does is it's going to seat into a hole inside the housing. So if you look inside the housing, you'll see a hole where when we put that cartridge back in, that little nipple is going to slide into the hole. And what that is going to do is it's going to keep the cartridge from spinning. And then, so when the input shaft drives the rotor, It'll help keep this cartridge still while the rotor spins inside. So it's really important to get that pin lined up properly. And what's also very important is that we don't want to smash or deform this nipple, because if the end of this starts mushrooming out, then it won't fit properly into the hole inside the housing. So we want to take care not to let this cartridge slide down forcefully into the housing, because that could end up causing damage to the nipple. So Kyle's going to give me a hand with this. We're going to note our position of our nipple compared to the hole. I'm going to slide that onto there. Okay, chances are it's not going to go on very easily, so we're just going to give it a little bit of lubrication. Kyle just has a pry bar in there just to support the cartridge in case it does fall down forcefully. He's just going to be able to stop it from falling down and contacting that nipple. Okay, use a chunk of wood to protect the pump surfaces, and then you're just going to okay, as you can see there, it slid down. If Kyle wasn't holding it, that whole cartridge would have slammed down into place and possibly damaged that nipple. Okay, so the cartridge is almost all the way down, but not quite. So we got a little chunks of wood on there. Again, we want to try to keep this whole thing as clean as possible when we're reassembling, just to prevent any contamination. Okay, so as we can see from this view, the cartridge still isn't seated down into the housing. You can still see the nipple up there, and you see this space here, so it tells me that the cartridge isn't seated all the way. We need to make sure that it's down all the way before we attempt to reinstall the second piece of the housing. So now what we're going to do is just tap it down a little more until it seats. I can tell from looking at here that I can still put my screwdriver in there, and I can still see that the nipple isn't seated into that hole. As a quick safety tip, you don't ever want to be sticking your fingers in there, because if that cartridge shifts or it falls down and your fingers are in there, then good chance of hurting them. So what we're going to try to do is just turn this cartridge just a little bit clockwise in there, just until that nipple finds the hole that it's meant to be in. We don't want to hit it too hard because we don't want to deform any of the metal. Okay, so now what we've got is we've got our pump cartridge back in our housing, and as we saw earlier, there's no gap where the cartridge is sitting down inside the housing. So that way we can be sure that the nipple is lined up and recessed into that hole, and that this cartridge is sitting all the way down where it needs to be. And again, if you took note earlier where this seal was in relation to the housing when we took the whole thing apart, you'd be able to tell again that that's sunk down far enough. So again, you'd use a little bit of hydraulic oil, because these are those two seals. Here's the main seal with the Teflon backing ring, and here's a seal. And what they do is direct all the pressurized fluid coming out of this port to go out of the pressure port in your housing. So now we're ready to reinstall the pressure end of your housing. Just make sure everything's clean, that there's no chunks of metal that have fallen down into it that are going to contaminate the system. And then again, we want to check this rubber O-ring right here and make sure that there's no damage to that. So the other thing we're going to want to do now is when we're seating this piece of the housing on, we're going to want to make sure that our ports are lined up in whatever orientation we want them to be in, based on how it has to get reinstalled back into the unit. So one of the first steps today we did was we made our marks on the two pieces of housing. So now what we're going to want to do is make sure they're lined up, make sure our ports are lined up the same way that they were when we took it apart, or the way that they need to be once it's back in the power pack. And then we're just going to slowly start seating these two pieces of housing back together. What we can do, reinstall our bolts, and then we can use the bolts to torque down the two pieces of housing. Okay, one thing we want to do, just like as if we were changing a tire on a car, we're putting a new tire on a car, we're going to want to tighten it in a bit of a star pattern so that the housing isn't getting pulled down one direction more than the other. Okay, so there we have the bolts put back in place. As we can see, we've got absolutely no gap here between the two sections of housing. What we can do, we can spin, and we can see that our rotor is still turning inside the pump housing easily, and all the bolts are torqued down to spec. Now, of course, just like anything else, the torque that we're putting into these bolts is going to be relative to the size of the bolt. So you want to make sure that these are 5/8 bolts. Whatever bolt you're putting in, you want to make sure you're torquing it to the corresponding ideal torque for that size bolt. Okay, so now that we've got the pump completely reassembled, the cartridge changed, and it's all ready to install in the power pack. So once it gets mounted again on the gearbox, there's a couple key points that I want to go over before we sign off. First one's going to be, currently the whole pump there is full of air. So there's no hydraulic oil in the cartridge. We got to make sure that there's hydraulic oil in here, and we purge out the air from the cartridge before we start the engine up. So once you get your hoses put back in place, the other point that we really want to make is you absolutely have to remember to open your suction valves on the bottom of your hydraulic tank. If you start up this pump without your suction valves being open, without a supply of hydraulic oil, you will cavitate the pumps and you'll destroy them very quickly. What I like to do is when I take the key out of the ignition when I first start, put a red tag on the key that says reopen suction valves. So before you ever start up the engine again, you see that red tag reminding you to open your suction valves. Put your hoses back on, purge the air, reopen your suction valves, and then it's all good to go. You start your engine back up, make sure that there's no leaks, watch that your pressure hose is holding properly, and then you're back to work. Okay, so that's going to conclude our video on the disassembly, repair, and reassembly of a hydraulic vane pump. If you're ever in the field and you have to do this and you have any questions or doubts, please contact the maintenance staff and they'll help you guys get this apart and back together safely and effectively. Thanks a lot. We'll see you on the next one.